There are two questions given here, but in exam you can choose either question A or question B. Let me explain both A and B here. First, we'll start with question B. So here the question is, plot a graph showing variation of induced EMF with the rate of change of current flowing through a coil. So we know that for a coil with an inductance L, the induced EMF epsilon, which is equal to minus L into di by dt. So here L is the inductance and di by dt is the rate of change of current. So we know that for constant inductance L, we can say that epsilon is directly proportional to minus di by dt. So this relationship is linear, therefore as the rate of change of current di by dt increases, the induced EMF also increases. So we'll get the graph like this. Now let us take rate of change of current di by dt in x-axis and the induced EMF in the y-axis, epsilon. So we know that the rate of change of current increases, the induced EMF also increases linearly. So we'll get the graph like this. So this is a graph of variation of induced EMF for the rate of change of current flowing through a coil. Now let us solve second question, B question. Here the question is, a series combination of an inductor, capacitor and a resistor is connected across an AC source of EMF of peak value E0 and angular frequency omega. So the question is, plot a graph to show variation of impedance of the circuit with angular frequency omega. We know that a series LCR circuit, so inductor, capacitor and resistor, they are connected across an AC source of EMF peak value of E0. So EMF equal to E0 sine omega t. Now they are asking us to plot the graph to show variation of impedance of the circuit with angular frequency omega. So we know that the impedance of LCR circuit is Z equal to square root of R square plus XC minus XL the whole square. We can write 1 by omega C minus omega L the whole square. Here R is the resistance of a resistor and omega C is the reactance of the capacitor and omega L is the reactance of inductor. So we can say that this XC, which is equal to 1 by omega C, and XL, which is equal to omega L. Now let us draw the graph that shows the variation of impedance of the circuit with angular frequency omega. So let us take angular frequency omega in the x-axis and the impedance in the y-axis. So if we draw the graph, we'll get the curve like this. So here we have the point which is XC equal to XL, and in this area XC which is greater than XL, and after this curve XC which is less than XL. So this is the graph that shows the variation of impedance of the circuit with angular frequency omega.